In this lesson, we're going to work out the expected frequency of an event. Let's dive straight into the first example. We're told that you flip an unbiased coin 20 times, and you're being asked, how many times would you expect it to show up heads? Hopefully, common sense tells you that you'd expect it to show up heads 10 times. That's because if you've got an unbiased coin, the chance of it showing up heads is a half, so you'd expect it to show up heads a half of 20 times. That's 10 times. This doesn't mean that it's guaranteed to show up heads 10 times exactly, but it's the most sensible estimate you can come up with, 10 out of 20 times. This is the formula you need to work out the expected frequency of an event. The expected frequency of an event equals the probability of that event times the number of trials, or the number of times you are running the experiment. In this particular example, we're looking for the expected frequency of the coin showing up heads. That's going to equal the probability that the coin shows up heads on a single flip, so that is 1/2, times the number of trials. In this case, we are flipping the coin 20 times, so that's 20 trials. So all you need to do is 1/2 times 20 to get an answer of 10 times. I'll repeat what I said earlier. This should make a lot of sense. You would expect it to show up heads half the time, and if you're flipping the coin 20 times, you'd expect it to show up heads 1/2 of 20 times, which is 10 times. In question 2, it says you roll a fair die 60 times, and we're being asked, how many times would you expect to get a 6, how many times would you expect to get an even number, and how many times would you expect to get a square number? First things first, we've got a fair die, so each outcome, the 1, the 2, the 3, the 4, the 5 and the 6, are all equally likely. So each of those has a probability of 1/6. For part A then, we would expect the 6 to show up 1/6 of the time, and we're rolling this 60 times, so the calculation we would want to do is 1/6 times 60, and a 1/6 times 60, or a 1/6 of 60, is 10. In part B, we're being asked, how many times would you expect to get an even number? Now, there are 3 even numbers on a die, 2, 4 and 6, out of 6 possibilities. So the probability of getting an even number is 3/6. You could simplify that to 1/2 if you like. We want to find 3/6 of 60. The 3/6 is the probability of the event getting an even number, and 60 is the number of trials. So 3/6 of 60, or 3/6 times 60, is 30, which makes sense. Remember, 3/6 is just 1/2, and we would expect to get an even number half the time. In part C, we're now considering square numbers. There are 2 square numbers on a die. You've got 1 and 4. 1 is simply 1 squared, and 4 is 2 squared. So 1 and 4, that means you've got 2 outcomes out of the 6, or a probability of getting a square number of 2/6. We multiply this by the number of trials, that's 60, and you get an answer of 20. So when you roll a die 60 times, you would expect a square number 20 times. Question 3 says, Karen takes the train to work each morning. The train has been late 17 times out of the previous 340 journeys. How many times would you expect her train to be late in the next 8 weeks, consisting of 40 working days? We're being asked to find the expected frequency of the train being late. Just like the previous questions, we need 2 bits of information to work that out. We need to know the probability that the train is late on a single journey, and we need to know how many trials we're considering, or how many journeys we're considering. The question doesn't tell us the probability that the train is late, but we can work it out. To be more precise, we can work out the relative frequency of the train being late. Now remember, relative frequency is not a frequency, it's an experimental probability. In this case, it is simply 17 over 340. That's the probability that the train will be late based on the recent evidence. We need to multiply that by the number of trials, the number of times Karen is going to take the train in the morning over the next 8 weeks. So that would be 40 times. We only seem to be considering the morning trains in this question. So the number of trials is 40. If you have a calculator, you could work it out using a calculator. Otherwise, you could spot that 17 over 340 can be simplified to 1 over 20. 17 goes into the numerator and the denominator, so we can simplify. So 1/20th times 40 is simply equal to 2. So you would expect the train to be late twice, or 2 times in the next 8 weeks.